So now here you can see. Okay, we what we were doing in the last class, did some questions, right?
So some questions we have discussed, problems.
Okay, work completed, kinetic energy, potential energy completed, right?
Sir, I'm having some doubts in circular motion. Can I ask?
Okay, okay.
Sir, generally, so in circular motion, we say that we can take the reference point and anywhere, no, sir, as origin. So
Okay.
does the reference line should always pass through origin, sir?
For what? Like what you have to depend on what you have to find.
So for finding angular velocities or anything, in general cases.
Yeah, so angular velocity depends on the point about which you are finding. So if they have not mentioned anything, you will always, by default, you will take center of the circle only. Because angular velocity of a body in circular motion about different point will be different. For example, if a body is there and the body is moving in a circle, can you see this diagram?
Yes, sir, I can see, sir.
And if the body is moving in a circular path, first of all, you have to understand what is angular velocity. So, angular velocity is simply the rate at which angular position is changing. Now, the thing is that if suppose a particle goes from one point to, let's say, another point, and this is the angle subtended, okay? So, the particle goes from this point to this point through this curved path, circular path, right? The angle that particle rotated about the origin, about the center. This angle is, let's say theta. Okay, this angle is theta. Now, if you are saying that, okay, I want to find angular velocity not about origin, but about some other point. You are saying that I will take a point on the circle itself. Then the angle that it is rotating is different, no, about this point, because the angle that it is rotating about this point is this only. Are you getting? And in mathematics, you already know na, that this angle is half of that angle, right?
Yes.
So the angle rotated in the same time about this point is different. If that is theta, this is theta by 2, right?
Yes, sir. It's theta by 2, sir.
So then angular velocity is different, no? Because angular velocity is the rate at which the so angular displacement by time and angular displacement here is different. Here is different about this point. So this point let's call O dash. So about O dash angular velocity is different than O. So omega of that particle about O is not equal to omega about O dash, and so that point is important. So by default, if nothing is said and is saying that angular velocity of particle is this, or they are saying find the angular velocity of this particle, which point you will take? You'll pick O. Simple.
So means angular velocity depends only on the origin, but not on reference line. We can say, no, sir.
Not on the no, not on the reference line. Yeah, means,
Sir,
but it depends. Yeah, but the thing is that you are finding about a point. No, you can say that the angular displacement is change in angular position. Sorry, angular displacement is change in angular position. But then that so angular displacement is here important, not the angular position. Means from different reference line, maybe angular position will be different, but then angular displacement will be same. But the point here is that because you want to find the angular velocity about the center, you will take reference line passing through the center. No?
Yes, sir. We take passing the centers.
So then you take any reference line, that does not matter. But it should be passing through center. You can ask it out.
So that's reference line always should pass to the origin, sir. Or the origin and reference line can be at two different positions we can take, sir.
Origin is not important. First of all, there is no origin in this discussion. There is center of the circle.
So generally we take center of circle as origin, sir. But can we
Yeah.
take origin as center of circle and reference line as above the
No.
center of circle, sir?
No. Means you can take. That is not a problem. But the thing is that है ना, reference line by default is through the center. By default is passing through the center in the plane of the body. Because if the body is moving in XY plane, so the plane angle will be measured with respect to a reference line in the XY plane, no? Are you getting?
Sir, what's that? I'm not getting.
First of all, suppose there is a reference line, okay?
Yes, sir.
Anywhere. Now, how you will find angular displacement? What is the process?
So first we find angular position, final and initial, final minus initial.
So, angular position means
Angle
find
made
the
by
radius
the
vector,
radius.
no?
Yes, sir,
Yeah,
radius.
so that radius vector, yes. That's it. That is the general definition. So, because here when we say angular velocity of a particle moving in a circle, so then about different point it will be different, but there is about the center. So by default it is about the center, but you can take angular velocity of a body about of a particle about any point, that is, there is no restriction. But by default I am talking is in the plane of the circle passing through the center. That is the reference line. For example, and why you are talking circle? First of all, the circle is also not important, no? For example, this is, let's say, y-axis, and this is x-axis, and the particle is moving in a straight line. Then also it have angular velocity, no? Because position vector with respect to the particle will be changing, right?
Yes, sir.
Rotating, no? Then also there is angular velocity. This is general. This angle here will change or not as the particle moves.
Yes, sir, it will change.
Yeah, so that also. So now what is your reference line here? There is no circle and there is no. Are you getting?
Yes, sir. So means always the reference line and the origin means should coincide, sir. Means
Yeah, so origin means, yeah, means with respect to a point you are talking, no? So that point we will call as origin. Means anyway, the position vector by default starts from origin. So where there is discussion about origin and that point, because position vector always starts from origin, no? By
Yes, sir.
default. So your confusion is because of the radius vector. It is not radius vector, first of all. It is position vector by default. And in case of circle, we call it as radius vector, which is not wrong. That is also correct, right?
Yes, sir.
But generally, we will simply call it as position vector. Now again you can ask your what is your
So what the difference means continuation position and radius vectors. Means in circle we can say both same, but in general
yeah
its position
general
must.
this is that does not matter like only it depends on the question what they are asking about which point they are asking angular velocity. That point will take origin because by default position vector will start from that point, no?
Yes, sir.
Origin. Okay. Now, so we already discussed the relationship between the potential energy and the conservative force, right?
Yes, sir. We discussed it.
So if U is a function of let's say XYZ, where U is the potential energy, then there's the relationship between the conservative force and the potential energy, right?
Yes, sir.
Okay.
Another doubt, sir.
Yeah. Okay.
So means so we know that angular velocity, angular acceleration are these are vectors, no, sir. We can say.
They are vector, yes.
So the direction can we take if the rotation is in anti-clockwise, positive and in clockwise, we can take negative, sir.
Yeah, it can be taken, yes.
Sir, or it also no be made into components like that, one we should consider.
Yeah, so means it depends. It will be always perpendicular to the plane of motion. Its direction is fixed. Now you can take component depending on where you are choosing your x-axis and y-axis. Means component you will take about what? X and y-axis you are talking, no? Components.
Yes, sir.
Yeah. So that depends on your choice of x-axis, y-axis. Suppose I am choosing z-axis in the direction of angular velocity, then it will be always along that axis. But if you say that no, suppose that the circular motion is there and circular motion is not in horizontal plane, is inclined like this, for example, right?
Yes, sir.
Now, if it is inclined like this, then also angular velocity will be angular velocity will be perpendicular to the plane of motion. So it will be in this direction. Now it is my choice. I will take z-axis in this direction. Are you getting? I can take no z-axis.
Yes, sir. We can take, sir.
I can take my z-axis along this direction, and then I will say angular velocity is along z. But if I take angular velocity along z, then this plane will be plane of the circle will become xy plane, right?
Yes, sir. Yes, sir. Sir,
So it will be along the axis. But now, if you say that no, I will take my x-axis, I will take my y-axis as this, and my x-axis as this. Are you getting? And then you will have to take components. It depends how you are taking axis, but angular velocity direction does not depend on the axis what you are choosing. Are you getting? It has a fixed direction, no? And that direction is perpendicular to the plane. So it just treat it as a vector, and now you can take component in whatever direction you want. But this is the direction of omega. Now component you can take depending on where you are choosing your x-axis, y-axis, right?
yes, sir.
So this is simply a vector. You can take its component, no problem. But the direction of vector will be always perpendicular to the plane of the motion.
Sir, means we can say that sir, either into components, we know that angular velocity is the rate of change of angular displacement, no, sir. So
Hmm.
can we say it has the if uh, if the rotation is in anti-clockwise direction, then angular velocity remaining all positive, and if rotation is along negative, we can say negative, sir.
So then that is again a convention. Means any one vector is negative of the other.
So then why we are using two conventions, sir, like in vector form and in this rotation as per angle.
Means where is two convention? Tell me.
So means here we are dealing with angles, no, sir.
Yeah.
Uh, means angles means in anti-clockwise positive, clockwise negative, no, sir.
No.
Similarly,
No. And
it's a convention.
similarly in vector.
Sim-
Similarly in vector.
Similarly, in vector we divide into components and we will say no, sir.
Yeah, so it's not like that, that anti-clockwise positive and clockwise negative, not like that. Any one
But it's a
direction
convention
positive,
just we follow,
opposite
no,
to
sir.
that will be
Either we
negative.
take in the reverse direction. Or...
Yeah, but that is the direction of angular velocity, no? So there is no confusion here. What is the confusion?
Sir, I'm with confusion and sign conventions of angular velocity and acceleration, sir.
And acceleration means angular acceleration you are talking.
Yes, sir, angular acceleration, sir.
So what is your confusion? That if you ask, then I can clear.
Sir, as per the rotation, can we decide, or as per the right hand thumb rule, also we can define, sir?
Yeah, no, as per rotation we can define.
Sir, but that you said the direction is obtained by the right hand thumb rule, no, sir?
Right hand thumb rule, but then your right hand you will curl in the direction of motion only,
The
no?
thumb finger
Means
was the
if the
direction.
motion is means right hand thumb rule simply says that curl your finger in the direction of motion. So it is the same thing, no? If it is moving like this, if it is moving like this, I will curl my fingers in this direction. In right hand thumb rule,
Yes, sir.
in which direction you will curl your fingers? In the direction of motion. So it
Yes,
is
sir.
linked to the direction of motion.
Okay, sir. Yes.
So always do not remember any convention. Always follow the direction of motion. According to that, you decide.
Sir, your voice is breaking, sir.
Okay. Is it
Oh,
clear
sir.
now?
So now it is clear, sir. Sir, according to what we should consider? The right hand
According
thumb.
to that motion, direction of motion, right hand thumb rule, and same thing. Both are same thing. Now, what is difference? Hello,
Yes, sir. There is no difference.
hello. So there is no difference because direction of motion will change. Then right hand thumb rule, thumb direction will also change accordingly.
Yes, sir. Yes, sir.
Both are same thing exactly.
Sir, we know that V equals to R omega, no, sir.
Yes.
Sir, here V is the speed, no, sir. We need to follow V as the
V
linear
is
speed.
the linear speed. Yes.
So then here omega is the linear angular velocity, sir.
No, omega is simply angular velocity.
So, but so we should consider angular speed, no, sir, because the sum
Yeah.
should be.
So there is no problem. Angular speed only means angular speed only, not angular velocity. Angular speed. It is angular speed only.
Angular speed. Yes. Sir, in the similar tangential acceleration as R, yeah, R alpha, we know, no, sir.
Tangential acceleration as r alpha. Yes.
So there also we need to consider it as R
Magnitude
as
of magnitude.
magnitude.
Yes. At is also magnitude. Alpha is also magnitude of alpha vector.
Yes, sir. Sir, sir, from
Hmm. Hmm. Tell me.
ER and ET along radial and tangential directions.
Hmm.
Uh, Sir, it is because that to make the calculations easier, we have discussed, you know.
What?
So, I mean, since the position vector changes, angle changes, so to avoid the confusion, we have discussed, no, sir, in that way. We can say.
In which way?
So, I mean, we have taken the unit vector ER and ET along the
Yeah,
along,
yeah, yeah. Because that always changing no direction. That's why not fixed direction. Means the radius vector, velocity vector, linear. I'm talking not angular. Angular linear velocity vector and that radius vector. They keep changing, no. So if something is always changing, if we will represent it by I cap j cap, then magnitude will keep on changing, component magnitude, right? For example, you will write now v cos theta I cap plus v sin theta j cap,
Yes, sir.
but the theta is changing. So v cos theta, v sin theta will have different value at different time, right?
Yes, sir.
But if you write v into et cap, then v is always same. And this is a good representation now, because in uniform circular motion, v is not changing now. Only et cap is changing. Are you getting it?
Yes, sir. I'm getting, sir.
That's why.
Okay, sir. In 80 carbon 80 is changing. Sir, centripetal force is not an independent force. No, sir. It is a resultant of some force acting towards center. No, sir.
First of all, centripetal force is not any force.
Yes,
For
sir.
example, in Newton's second law, what is the Newton's second law? F net is equal to
Yes, sir.
ma. Now, what you are saying that, sir, is this any force? This is not the force. No, this is the force, right?
Yes, sir.
That is the problem. So when you say mv square by r is ma, which is resultant of all the force which is acting. So we should not talk about ma. We should talk about all the forces which are acting, right? Because ma is a resultant of all the forces only. Ma itself is not any force, right?
Yes, sir.
Yeah, that is the thing. Ma itself is not a force. It is a resultant of all the force whose value is equal to mass in rate of change of momentum, and that's why it becomes ma.
Yes, sir.
Okay.
Yes,
You
sir.
can ask your doubt.
So 1 minute, sir. I'm checking. So generally we say in kinematics, speed and velocities are different now, sir, quantities. Even in this formula, at equals to r alpha and v equals to r omega, even we consider the magnitudes of acceleration and angular velocities and angular acceleration, it is we get correct answers on this one. Means when we think practically, sir.
Means I'm not getting what you're saying. Again, can you repeat?
Sir, generally, sir, in the kinematics, we will consider velocity or speed as different quantities, no, sir.
Okay.
Mm. Sir, in all cases, the both cannot be equal, no, sir. In some cases, it may be equal.
Means what? What may not be equal?
Velocity and speed, sir.
Velocity and speed can never be equal. No, not in any other case also. Only their magnitude are equal, always equal. Their magnitude is always equal.
Yes,
I'm talking
ma'am.
about instantaneous. Yeah. The magnitude of instantaneous velocity is nothing but instantaneous speed. That's it. Always. This is always true. Now tell me.
So in the centripetal acceleration also, v is the magnitude of means magnitude of velocity of speed we should consider, no, sir.
Means it is v square by r, no? Speed square by r.
Yes, sir.
How it is v? V square by r, no? Dimensionally, it could be dimension of acceleration, no?
Yes, sir.
If you check v square by r, its dimension is the dimension of acceleration.
Sir, in
Why
the
is that?
80, yes, sir. Sir,
Okay.
in 80 equals r alpha. Alpha is the magnitude of angular acceleration. Only.
Yeah, everything is magnitude. Why you are only focused on alpha? V 80 is also magnitude. R is also magnitude. So alpha is also magnitude.
Yes, sir. Sir, you explained a concept of circular turnings on banking of roads, no, sir.
Okay.
Sir, there I'm not getting why the friction is acting towards the center, sir. Because the wheels,
Friction is not acting towards the center. Friction always acts tangential to the surface, right?
yes, sir, but we
And
equated
then
the
its
friction
component we
to
will take towards the center. Its component will come no towards the center.
So then we should write either f cos theta or f sin theta. No? So, but directly we are equating friction to mv square by r. No?
No, we cannot. We cannot directly equate a friction to mv square by r because friction can never be towards the center. Friction will be always along the surface. No?
Yes, sir.
So if this is the block and block is moving, okay, how friction can be toward the center? The friction, if it is moving with very large velocity and has tendency to slip upward, in that case friction will act downward. And friction will act downward, then only we can take its component toward the center. We cannot take friction toward the center. No? Situation will be somewhat different, not this one. Yeah, if it is horizontal road, then definitely friction towards the center. So here it will be f cos theta, which is toward the center. Right.
Yes, sir. Sir, can you give it? Sir, can you explain again the directions of angular velocity and angular acceleration? Sorry.
Always perpendicular to the plane of motion. So angular velocity and angular acceleration you are talking. So direction of, first of all, you have to understand the direction of angular velocity. Okay. Direction of angular velocity is always in the direction of angular displacement, and it is given by right hand thumb rule. Now, the direction of angular velocity and angular acceleration, they will be exactly opposite to each other if the body is slowing down. Slowing down means what? Slowing down means magnitude of omega decreasing with time. Magnitude of omega vector decreasing with time is decreasing. If it is decreasing, angular acceleration must be opposite to the angular velocity.
Yes, sir. Understood.
This is the concept. And if omega is increasing, then both in the same direction.
So we know that v bar equals to omega bar cross r bar. In that, that is relation. Then
That
we,
is
the relation is applicable for angular velocities only, no, sir. And
that now
velocity.
that is angular velocity. Everything is vector now. That r vector is the radius vector and v vector is the velocity, linear velocity vector. So now everything is vector. Yes.
Yes, sir. Sir, understood.
Okay. Any other doubt?
So that's also no difference.
Okay. So now we can go to the questions. So now here you have to understand that total mechanical energy of a body, we simply write it as kinetic energy plus potential energy. That you already know. Now, once we are done with all the mechanical energy, work energy theorem, everything. So now you can jump to vertical circular motion. So just give me 1 minute. Something is missing. So the missing thing is this conservation of mechanical energy. So now let's talk about the conservation of mechanical energy, which is very important. Conservation of mechanical energy, first of all, you have to understand that mechanical energy of a body is not always conserved. Okay. And second thing, you have to understand that many a time we call mechanical energy as total energy, which is also not correct. Mechanical energy is only kinetic plus potential, right? So mechanical energy is always kinetic plus potential. Is it visible to you? The screen is visible to you? Hello. Are you there?
Sir, now you're audible.
Am I audible?
Sir, now you're audible.
Okay. So Yeah, so now we are talking about conservation of mechanical energy. Here you have to understand that mechanical energy, we also call it as total energy, but that is not correct. It is simply sum of kinetic and potential. Okay. So kinetic and potential energy of a body you add, it becomes mechanical energy. Now, mechanical energy of a body or of a system is not always conserved. That is what you have to understand first. It is conserved only in that situation in which conservative forces are doing work on the body, and there is no external force doing any work on the body, and no non-conservative force doing any work on the body or the system. So if on a body or on a system there are only internal conservative forces doing work, then and then only its mechanical energy remains conserved. Now mechanical energy remains conserved means sum of kinetic and potential will remain conserved. Kinetic will change. Kinetic and potential may change, but their sum will always remain constant. Now, the more important thing is that when it remains constant, when only internal conservative forces does work on the system. Okay.
And external forces should not be there, sir.
Sorry.
External forces should be absent.
External forces could be there. Any force could be there, but they should not do any work.
Okay, sir.
Problem is not there with force. Problem is forces should not do any work. The
Your
work
voice
should
is
be only
breaking.
done by the conservative force. Only conservative, internal conservative force should do the work. So for example, if you release a stone from the top of the building, now you can see that if I ignore air friction, then only conservative force is acting on the body. And then the mechanical energy of the body remains constant, loses potential as it comes down, and it gains kinetic. So
Yes,
sum
sir, your
always.
voice is breaking and I'm unable to understand.
Okay. Now is it okay?
Sir,
Yeah.
sir, breaking sir, means breaking and coming, sir, in between, sir.
Okay, 1 minute. So let me rejoin.